Today, I am going to show you how to find all roots of this polynomial equation x to the power of 4 minus x to the power of 2 minus 2 equals 0. I can tell that this polynomial is going to have two sets of binomials with a quadratic binomial degree. To separate this polynomial into two sets of quadratic binomials, I am going to use one of the properties of exponents to separate x to the power of 4. So this will become parentheses x to the power of 2 and raise this whole expression to the power of 2. This is because if you were to multiply these two together, it will come back as x to the power of 4. Then minus parentheses x squared and then minus 2 is equals to 0. The reason why I did this because the terms inside the parentheses indicate that this polynomial can be separated or factored, so to say, in two sets of quadratic degree binomials. Now, we must find the missing terms. Pick two numbers that has the product of c, which is negative 2, and when combined together, it has the sum or difference of b, which is negative 1. You can solve this into your mind or use the star factoring method to find the missing numbers. The two missing numbers are negative 2 and 1. Now place each of them into the two sets with negative 2 on one set and positive 1 on the other. Now see if we can factor these two sets or break down even more. However, we cannot factor this one out, leaving us to solve for x. So it will be x squared minus 2 is equals to 0 and x squared plus 1 is equals to 0. Solve this one first. Plus 2 on both sides. It will become x squared is equals to 2. Apply square root on both sides and it will become x is equals to plus or minus square root of 2. Then minus 1 on both sides, it will become x squared is equals to negative 1. Then apply square root on both sides. It will become x is equals to plus or minus 1i. Overall, this polynomial equation x to the power of 4 minus x to the power of 2 minus 2 equals 0 has 4 roots. So it is x is equals to square root of 2, negative square root of 2, 1i or I, and negative 1i or negative I. And our polynomial equation has been solved.